Welcome! In this video, we are now at MELC 2 week number 3, Applications of Radio Waves, Microwaves, and Infrared. In this module, you will cite examples of practical applications of different regions of electromagnetic waves, such as the use of radio waves in telecommunications. For the background information, you need to read this, because this might help you in answering questions below. But I will supply or add videos about radio waves, microwaves, and infrared. After reading this, let's go to the next page. Activity number 1. Radio waves are EM waves found at the left end of the EM spectrum, arranged from low frequencies to high frequencies. They are the type of the EM waves with the longest wavelength, but they are of low frequencies, thereby carrying the lowest energy from among the EM waves. To better understand this, let me show you a video.
In the modern era, radio waves control everything, from the tunes in your car driving down the road, to the police radio and the cars that pulling you over for not signaling your turn. These waves are undetectable and invisible to human senses, but they make up the foundation of modern connected technology. While the root of modern connected technologies may be radio waves, the underlying tech that makes radio waves possible is a rather simple concept to understand. Any person can make a simple radio in their home and very affordable, which is a part of the reason this foundational communication tech takes back to 1895 as a demonstrable introduction to understanding what radio is. We'll engage in a simple explanation of how you might make one. All you need is a battery, a coin, and then AM radio. Tune the radio to a static channel and start tapping that coin on the two terminals. You'll start hearing the tapping through the AM radio. By doing this, you'll have made a crude radio transmitter, capable in communicating in Morse code or random taps, over just a few inches though. What you're doing in this process is exciting electrons on the transmitter side, the battery and the coin, which then is received as a signal on the receiving side. The AM radio tunes back into an audio output. What you're doing is completing a circuit between the battery terminals, which creates an electromagnetic force, which can be detected by the receiver in the AM radio. In order to understand radios in more detail than what we just discussed, we need to take a little trip through history. Back the early days of radio technology and the whereabouts of the early 1900s, radio transmitters were referred to as spark coils. This was due to the fact that they create large high voltage sparks, upwards to 20 kilovolts to send out signals. The issue was the message was sent out on all frequencies in radio spectrum, meaning that there was essentially only one localized channel. This was fine back in the days where no one was really using the radio, but nowadays, do something like this and you'll get fined or sent to prison. These early spark coils were essentially doing the same thing as the coin and battery experiment, except at a much larger scale, meaning that they had a lot higher range. Every single radio has two parts, a transmitter and a receiver. The transmitter is responsible for taking a string of data and encoding it to a sine wave. After that encoding happens, it can also be amplified and sent out across the air. The receiver rather expectedly receives the radio waves and decodes the message encoded into the sine wave. Each side of the system uses antennas to radiate and or receive the signal. Relating radio back to your life a little bit, chances are you are watching this video as a result of transmission of radio waves. Cell phones use radios in their most basic form. They contain both transmitters and receivers and can run both at the same time. In general, phones use frequency modulation or FM in a frequency range of 800 MHz in any one of 1600 individual frequencies. All of those numbers and data probably is meaningless to you right now, but hang on as we dive deeper. Back to our simple battery, we can recall that an electromagnetic force was created when the battery circuit was completed. Finally, frequency modulation, otherwise known as FM, is used for FM radio and tons of other wireless tech. In this encoding technique, the sine wave frequency changes slightly based on the signal. This means that the distance between the peaks of the waves is varied based on the data that's trying to be transmitted. Bringing all these different techniques back into the real world, we can begin to understand them a little further. If you sit in a car or jeep, listen to the radio to AM 680, that means that the transmitting station was operating at 680,000 Hz, meaning that the sine wave repeats 680 times per second. The voice of the speaker or the music on the transmitting side is modulated onto that wave through amplitude modulation. Then the signal is amplified up to 50,000 kilowatt for larger AM radio station and then sent to the space utilizing their antenna. Your car's radio picks up that signal using its own antenna. This can be as simple as a wire or a metal stick.
Then these are the questions that you need to answer under the radio waves. So copy the questions and supply the answers below. For the next activity number 2, microwaves. These are not only used in communication, but it is popularly known to be used in cooking. A part of microwave oven produces microwaves which are sent to the reflecting fan. The microwaves are reflected in many directions by the fan and the walls of microwave oven. As microwaves pass through the food, they transfer energy to it in the form of heat. This heat energy cooks the food. And I will show you another video for this, or about microwave. Let me show you.
Microwaves can pop your popcorn. They can catch your speed. They carry thousands of phone channels to speed your calls, with wavelengths ranging from 30 cm down to 1 mm. Microwaves fall between radio waves and infrared. Microwaves are used in Doppler radar, which is widely used for short-term localized weather forecasting. And what you see on TV weather news, satellites have revolutionized weather forecasting by providing a global view of weather patterns and surface temperatures. This unique perspective has greatly improved the accuracy of tropical storm and climate forecasts. Different wavelengths have microwaves, grouped into bands provide different information to scientists. Medium wave C-band microwaves penetrate through clouds, dust, smoke, snow, and rain to reveal the Earth's surface. Satellite microwave measurement reveal the 4 Arctic sea ice. Every day even clouds where exist. These measurements show great variability from year to year. Had also an overall decrease in Arctic sea ice since the late 1970s illustrated here with maps, and the time series of Arctic sea ice in September at the end of summer melt. The Japanese Earth Resource Satellite uses longer wavelength L-band microwaves for forest mapping by measuring surface area moisture, such as this image of the Amazon basin to identify areas of recently deforestation. L-band microwaves are also used by global positioning systems, such as the one to cars and cell phones. Scientists routinely combine microwave information with information from other parts of the EM spectrum to study the composition of cosmic dust or the supernova. Such the supernova image that combines X-ray, radio, and microwave data. This recently known supernova in the Milky Way exploded just over 140 years ago at the time of American Civil War. One important phenomenon is unique to microwaves in 1965. Using long L-band microwaves, Arno Penzias and Robert Wilson made an incredible accidental discovery. They detected what they thought was noise from their instrument, but was actually a constant background signal coming from everywhere in space. This radiation is called cosmic microwave background, and if our eyes could see microwaves, the entire sky would glow with a nearly uniform brightness in every direction. This existence of this background radiation has served as important evidence supporting the Big Bang theory for how our universe began. Microwaves have become both staples and wonders of modern life. They are also the backbone of communications and of Earth sensing systems, and they are an excellent guide to the ancient history and origins of our universe.
So these are the questions that you need to answer about microwaves. So again, copy the questions and you write the answers below. For the activity number 3, infrared. So nowadays, many of the devices like the wireless headphones, keyboards, mouse, telephones and technologies like in car locking systems, navigation systems, and home security systems utilize or uses infrared. Infrared technologies offer numerous advantages in wireless communications because it requires low power, low and simple circuitry, and portable. It has a higher security than radio waves since it requires line of sight transmission and do not likely interfere to signals for other devices. And to show you another example about this, let me show you a video.
When you use a remote control to change channels on your TV, your remote is using light waves, but this light is beyond the visible spectrum of light you can see. Back in 1800, William Herschel conducted an experiment measuring the temperature changes between the colors of the spectrum, plus one measurement beyond visible red. When that thermometer registered a temperature warmer than all the other color, Herschel had discovered another region of the electromagnetic spectrum, infrared light. This region consists of short wavelengths around 760 nanometers to longer wavelengths about 1 million nanometers or about 1000 micrometers. We can sense some of this infrared energy as heat. Some objects are so hot they also emit visible light, such as a fire. Other objects, such as humans, are not as hot and only emit infrared waves. We cannot see these infrared waves with our eyes alone. However, instruments that can sense infrared energy such as night vision goggles or infrared cameras allow us to see these infrared waves from warm objects like humans and animals. Infrared energy can also reveal objects in the universe that cannot be seen with optical telescopes. Infrared waves have longer wavelengths than visible light and can pass through dense regions of gas and dust, scattering and absorption. When you look up at the constellation Orion, you see only the visible light, but NASA's Spitzer telescope was able to detect nearly 2,300 planets in the Orion Nebula by sensing the infrared glow of their warm dust. Each disk has the potential to form planets in its own solar system, incoming ultraviolet, visible, and a limited portion of infrared energy, together sometimes called shortwave radiation from the sun drives our Earth system. Some of this radiation is reflected off of clouds and some is absorbed in the atmosphere. Larger aerosol particles in the atmosphere interact with and absorb some of the radiation, causing the atmosphere to warm. The heat generated by this absorption is emitted as long-wave infrared radiation, some of which radiates out of the scope. The solar radiation that does pass through Earth's atmosphere is either reflected off snow, ice, or other surfaces, or is absorbed by the Earth's surface. This absorption of radiation warms the Earth's surface, and this heat is emitted as long-wave radiation into the atmosphere, which allows only a small amount of radiation out to space. Greenhouse gases in the atmosphere, such as water vapor and carbon dioxide, absorb most of this emitted long-wave infrared radiation, and this absorption heats the lower atmosphere. In turn, the warm atmosphere emits long-wave radiation, some of which radiates toward the Earth's surface, keeping our planet warm and generally comfortable.
And these are the questions that you need to answer under infrared. For the reflection part, you need to complete the statements below. So I understand, I don't understand, and I need more information about. So you just put in all your answers below by copying the questions. So that's it. That's the end of this video, and I hope I helped you a lot, or this video helped you a lot. If you have more questions, you may comment your questions below, or you can send me a direct message. Thank you.